Did nature create itself? I've got to pick up the pace and talk as fast as Dr. Faulkner does. This is an important one. Look at this. This is an incredible feat of human engineering. Wow, it's kind of getting cut off there a little bit. I have never had so much issues with my technical stuff. It's an amazing thing. I think our enemy doesn't want to get this message out because this is like a cutting edge scientific message. And this is just an amazing thing. Well, this is being built by the Navy. It's a new vessel, look what it says, patrol the world's oceans in the yellow part without a single human on board. The defense, or DARPA, that pioneers tech for the U.S., created the anti-submarine warfare. And this thing, this ATCU, this ATCU vehicle right here, is going to search for enemy submarines on that. The next level, tracking, is going to have all kinds of sensors, which are going to be able to detect even the quietest enemy submarines and hunt them down. And evidently, once it gets on their tail, they're doomed for that. And look what else it says. Not is it going to have that, it's going to have logic. And it's partially cut off here. It says that this machine is going to be smart and counteract and outmaneuver all these enemy submarines. Now this is an incredibly sophisticated device. Incredibly sophisticated device. And you have an entity relating to its environment. You have this ship relating to this submarine, which is a part of its environment. And so we ask the question, is the sub causing this ship's adjustments? That's a really good question. Is it causing those ship adjustments? Or is this ship adjusting itself? Is the ship adjusting itself? And the only way you really know is if you can look inside to know on that. And we are able to do this. And when we look inside, we're able to figure out that this ship is able to adjust itself. And so this is what we want to resolve today. When you have a condition and you end up with a result, such as this burned out wasteland over here, hot, dry, and everything, and now you end up with a dog with short hair, small body, able to live in that kind of environment. How in the world does it get there? You have a condition and a result. Does it get there via this route? You have all different kinds of varieties of dogs. And then those terrible conditions kill off nearly all the dogs until you're left with just a few or a single one that's able to what? Survive in those conditions. Is that the way God designed it? That's the question we should be asking ourselves. Does this mechanism here glorify the Lord? I'm here to tell you that myself and most all my other researchers at ICR completely renounce this mechanism. You know, and to use in political terms, we disavow it, as people say. This is not a good mechanism, but this is the dominant mechanism whereby you get these kind of results. This is the mechanism that is currently taught almost everywhere. Is there a better way to explain how that happens? Or does the environment have some magical abilities to induce changes into organisms? Does it just induce them? How many of you have heard that phrase? This induced you, or this did that. Is that really true, or is that false? And do you get these kind of dogs on the basis of innate designed mechanisms that the Lord placed in them so that he could live in all different kinds of environments? Maybe there's a better way of looking at that. Well, as I mentioned yesterday, it's kind of cut off, so I'll just tell you what it says. It says, in everyday parlance, environmental stimuli is said to even regulate or induce the expression of specific genes. But nothing in the external environment, I'll paraphrase it here, can actually turn on any specific gene. So it's basically a system where everybody thinks that the environment is causing stuff to happen. Boy, we're going to have a lot of quotes, so I'm going to have to just go through some of these. I don't know why they're getting cut off. They weren't cut off 10 minutes ago, but now they are. So that's just too bad on that. Anyway, Is there a better is there a better way? Is there a better way on that? Would you please unplug that thing from the side of mine and replug it back in? And see if that will adjust it. Oh. Well, sorry, I got to grab something here while I'm at it. If you've got a good daughter or a granddaughter, he's in the Navy right now. He's in training in New York State. He's in the nuclear engineering program. And so he will have, when he finishes that off, he'll be stationed on an aircraft carrier for 4 years. And then he'll probably be a free man because I think he wants to get out and be a teacher or something along those lines. So that's what he's doing right now, and he should, okay, it didn't necessarily reset. He should be a pretty good catch for some guy. He's a nice guy, and I'll tell you one other thing. He's a good shooter. He's a football wizard. He played football in junior high and high school, and I don't know how he does it, but he's able to conceptualize defensive formations in his mind. And it's really hard to get through a football game with him because I'll be watching it, and they'll line up, and then he pushes pause, and he says, "This defensive guy's going to do this. This guy's going to do this. This guy's going to do this, and this is going to happen." And then he runs the play and this is not college ball. This is professional ball, and they do exactly what he says. And that he's like a football wizard. Oh well, we'll just continue on with this. All right, so what this is saying is that most biologists are trained to think that the environment causes changes in organisms, but it really doesn't. And I talked about the blind cavefish the other day. In other words, how do organisms relate to their environment over time? How do they relate? Do you go from a condition, which is in this particular case, total darkness, and how do you get this effect, this result, the blind cavefish? Did God have a plan for this? Is there a purpose for this relationship? Well, I'll tell you, the purpose is ultimately to glorify the Lord by showing incredibly complex ways where he expresses his designs. Because designing something static is very, very easy and simple, but designing something that is continuously dynamic is hard to do from an engineering standpoint. And since these organisms are continuously dynamic, they are able to rapidly adjust to things. And so we ask the question, these are going to sound similar, but they're very different. Do environmental challenges shape organisms over time, or do their innate mechanisms shape themselves to challenges over time? That's the important question. How does this happen? Well, we need to look inside these animals to find out, and we can now look inside of them and see how they are able to do these kind of changes over time. Well, this is going to take us back, and we're going to take about 5 minutes here to quickly go through a little bit of the philosophical background between two explanations called externalist and internalist, and they were debating even before Darwin got on the scene. Externalists basically go with the view that the environment shapes organisms. The environment molds and makes them. Their form is due to the environment. Internalists say no, their form is due to mechanisms within themselves. And their ability to self-adjust is due to mechanisms within themselves. And they have all these different names that they've taken on over time. Someone calls themselves a selectionist, adaptationist, and on. And the internalists are basically those opposite names, non-selectionist, a structuralist. And so you may read these different names, but Stephen Jay Gould says on this that one designation or the other, this will maybe save me some time, I'll just paraphrase him, divides and has divided biologists into two camps from the beginning, internal versus external. So you can't, it gets cut off, but that's what he's saying right there. And then another paper that was just recently published by Michael Denton goes on to say the same thing, that these people have been divided into these two camps for a long, long time. And the interesting thing is, initially externalism was thought of, the design was put in by the mind of God. It was external to them, which is really true. But then that kind of went away, and they started focusing on the creatures themselves, whether it was happening by the environment or whether it was coming from within the organisms. And it says here, this gal, Linda Medina, makes mention that the term internalist makes reference to the nature or the originating, organizing principle of biological form happening from within the organism. And externalists, this will cause you to be a speed reader here, sees that it is what? Imposed from without. Imposed from without. That's the two camps. One sees it coming from the inside, the other sees it as being imposed from the outside. And according to these paradigms, the externalists see the supposed design of organisms resulting from specific adaptations that are caused by natural selection, imposed by the environment, and are external to the organism themselves. So externalists see the environment causing it and see it imposing upon them. And therefore, when you turn to scientific journals and papers, you will see headlines like this by the dozens. How insect herbivores drive the evolution of plants. You have these insects that eat plants, and it's driving the evolution of plants. Or you'll see one that says geology and climate drive diversification. And you see the environment is running the show in their worldview. Dry conditions spurred the advances in photosynthesis, and the need to conserve water played a role in driving plants to evolve specialized form. The environment is basically running the show. Nature again. Evolution, geology, and climate drive diversification. And this is chapter 1 from a leading college textbook saying this: the environment as a normal agent in producing phenotypes. Phenotypes are your traits. Those are your body characteristics. That's your form. And not only do they see the environment as driving the show, in this particular case, they even see it as an agent. And they will assert in this book that nature can exercise agency. Now think about that. You can exercise agency. God exercises agency. You have a will. You make those determinations. But can nature exercise agency? Be careful on how you answer that. That has theological implications, profound theological implications. And therefore, I'll cut to the chase, this gal said, as a result, organisms in Darwin's externalist world are as passive as the matter that forms them. And she says, despite language like struggle for survival and all of that, in Darwin's world, the environment is active and organisms are passive. The environment shapes and molds and makes them. Does that make sense? And that's what they say. And this book, which was a leading evolutionary textbook, not just text, it was a theory book really, just published a few years ago, makes this. Darwin accepted the view that the cutoff word is the environment directly instructs the organisms how to vary. The environment directly what? Instructs organisms. This is why we need to really read carefully. The environment is instructing organisms. The organism was like, what does it say here? Modeling clay. The organism is modeling clay, and guess what the modeler is? The modeler is the environment. And this is how you can get God out of the picture and replace it with another substitute God, where instead of God being the modeler, the environment becomes the modeler. And organisms are passive. Please get this down, because this is how you are thinking right now. This is how you were trained. This is how everybody is trained. The environment does stuff to us. And we were trained in this world of naturalism, which dominates science education and theory, particularly vocabulary and even research projects, where all of us get trained in the naturalistic thinking, but a few of us say, well, but God was involved. And we come up with naturalistic explanations, which are essentially no different than the evolutionists, but we say, but just not as much as they say. You know what we need to do? We need to put a big X through this and reject this altogether and come up with a better explanation, a really, truly science-based explanation, and more important, a Bible-based explanation, which is based on here, Romans 1, and I don't even have to fill in the words because you have this down by memory, where God has revealed himself from the creation of the world by the things that are made. He's using the words of design. And therefore, the only way to push back against naturalism is to promote design, and more design. And the best way to argue with a naturalist is just keep showing them one design thing after another, until they cannot explain all of this without appealing to some magical force called natural selection to do it. So, that means that all of us have to know a little bit about how things work. Some of us are content to never know how anything works. But if you really want to push back against evolution, just like in the submarine and the fish, you have to look inside. You have to look inside a little bit and kind of understand how things work so that we can push back when they are asserting that organisms are modeling clay. Well, we know one thing, that from the very beginning of creation, the earth was always a very dynamic place. It says there was day and night. That's dynamic. It says there were signs and seasons. Those are dynamic. So God made a dynamic, challenging, changing world. Challenges are not sinful. Challenges in the world are the way that God will reveal how great his creation is, because you only know how great something is when you put it to a great test. Is that not true? That is true. That is true. You want to know how good human engineers are? Well, we'll send a man to the moon and back. You don't take on a trivial task. You take on a monumental task. Well, God demonstrates monumental tasks all the time. Therefore, since the very act of filling creation changes it, because organisms are constantly taking things out of their environment and putting things in, organisms had to be able to change themselves. Would you put a static thing in a dynamic environment? No, you would not. So God made dynamic organisms to fill his earth. And we need to therefore change our thinking about Earth's created conditions so that we have organisms. This said that are organisms that were stable, that reproduce after their kind, and then organisms that are also have a little bit of plasticity to them because they have to adjust the night and day and fill all the earth on those things. So organisms need to be robust, they need to be a little plastic, and therefore they need to be resilient and have interesting design characteristics on them. So this is what we need. And fortunately, in all the scientific literature these days, everybody's talking about drones or robots, and they can really teach us a lot. Here, this whole issue of nature was on robotic cars, and that no drivers required. Now, some of you are probably looking forward to that day, but I'm not. I'm one of those people who, I like to get into the car, and I like to drive it. When I get on the interstate, I-5, for me, it's a little competition between all the myself and the other cars on that. Is anybody else like that? I mean, I'm not sitting there passive like that girl, like a sack of potatoes. It's me and the next guy out there. So I like that driving experience. But this is the main thing about these robotic cars. They're going to have ability, as it says here, highlighted perception. They have to be able to make decisions and take action, and they have to be able to communicate. You know what? That describes you. And that describes every creature that's on this planet. And it's doing it, I'm not saying even through your mind, it's doing it in an automated process, how organisms are able to do this. So this, fortunately, we have it. This is the key thing of any self-adjusting feature, whether it's man-made or God. You have an external condition which has a detector which will detect it, input, a logic center that says if this, then do that, and then outputs. And if you really want it to be automated, there will be a feedback which goes between those two on there. So this is the first design principle. Designed things are always self-contained entities. We relate to the environment so closely, you think, well, maybe we're not a self-contained thing. You are a self-contained thing. Just like a computer, just like that car, and just like that car is going to go up on cruise control, I guarantee you there will be, in its self-contained package, a speed sensor, a computer with a logic center, and an output that is going to enable this car to make its adjustments like it's supposed to. And here's a picture of planes. This is a military aircraft. It's a B-1 bomber. And when I was in the Air Force, that was the bomber that was at my base. And I was required to fly in that baby 4 hours a month. So I spent a lot of time flying that. And every now and then they would say, I usually flew in the back, hey Doc, do you want to come up and fly the jet for a while? You know what I said? Sure. Let me fly that jet for a little bit. So I'd unstrap and get up to the front, and I spent a good amount of time over here flying the jet. So it was a lot of fun. But most of the time when I was in the back, they would do these low-level bombing runs on terrain following radar. They would be zipping along at 600 miles an hour, only about 600 feet above the ground, and it would automatically adjust itself to the terrain, up and down. And you could even put it on autopilot, and it would do that. Let's make believe that you had a jet like this, and it could have terrain following radar and on autopilot. I guarantee you that within that jet, there will be a sensor, a radar, which will be able to follow the terrain. There will be a computer mechanism able to adjust it. Now the question then comes out, does the mountain cause the plane to fly over it? Does it cause it? You see, everybody's wondering, well, the mountain's there and the plane flies over it. Well, the answer is no. And how you know is by looking inside the plane. If I went inside this plane right here, I left it on autopilot, but I flipped the switch of the terrain following radar off. Then what does it do as it flies towards the mountain? It flies into the mountain. And therefore we know definitively that the mountain doesn't cause anything to happen. The plane is causing itself to adjust. Is that very plain? Oh, this is so important because I guarantee you everything from the evolutionary worldview is going to have the environments as causal. Environments as causal. Well, this is really important. The environment just is. It's just conditions of mindless, impartial, unconscious conditions that are just out there. And really, unless God supernaturally intervenes to cause the Red Sea to part or the ground to open and swallow up Korah and his rebellious gang, the environment just is out there. It's not really doing anything, and it's definitely not exercising agency. So, here's this quote back. It says, in everyday parlance, environmental stimuli are said to induce or regulate. Well, everyday parlance is very important, particularly when it comes to whether things are active or passive. Here's a movie made in the 1930s with Fred Astaire and Ginger Rogers called Shall We Dance? And it has this funny little song about silly semantics. You say tomato, I say what? Tomato. You say neither, I say neither. And then since they can't agree, they say, let's call the whole thing off on that. And I picked this picture because it shows a typical guy trying to woo a typical girl. And the look that you normally get. Something like that. It's just, that's it. Well, this is a kind of a playful song about semantics. But semantics are not always playful. For instance, active. Did this gal walk out her front door and lay down on the grass, or was she passively pulled out and thrown down on the grass? Is that semantics? She's out on the grass. Well, I'm here to suggest that causality is important. Causality is not simple semantics on things. So, if I say detector and you say receptor, one of them is indicating activity and the other is indicating passivity. And you'll see from the evolutionary worldview, everything on organisms are called receptors. Causality is not simple semantics, and I'll give you a quick illustration. Here's a gun that's on most ships. It's going to be on one of my son's ships. This says last-ditch defensive effort against high-speed incoming missiles, supersonic missiles. And this is a gun to try to shoot them down. And it has an ultra-rapid missile-detecting radar on it. And it has a super-fast Gatling gun that is attached to that baby, which shoots these 1-inch diameter shells that are like 2 inches long, and it shoots 100 of them per second. Zoom! It's like a steel rod out there shooting those babies down on that. Well, if you were on that ship, the last thing that you'd want is for your detector to become a receptor on that. A big difference between a detector and a receptor on that. In fact, the radar is so fast, they have on aircraft carriers, they have several of these. If they're both shooting at the same time, the radar can actually lock onto the individual bullets of the other one. That's how fast this is. It's operating faster than most of you and even me. So, if you look on the outside of a cell, this little molecule is called a receptor. Maybe we should change our thinking about it, that it's actively surveilling outside the cell, looking for what it's supposed to and designed to detect. And when it detects it, it activates itself. And causality is not silly semantics. It's going to hopefully differentiate between externalism, things imposed from the outside, versus internalism, things causing and happening from the inside. So here's a quickie example. Why don't plants get sunburned? They're in the sun all the time, but they don't get sunburned because they have a detector for ultraviolet light, even though they call it a receptor there. And as soon as it detects the ultraviolet light, within seconds, it's making compounds which act like sunscreen. And it puts them on the cell surfaces so it doesn't get sunburned. That's an active process. And causality is not simple semantics on how this works. So let's look right here at some of these detectors. And I want to look at 4 areas where organisms have some interesting detectors, and we'll see how design analysis can help us. First, number 1, that's what's cut off. Sensors that detect or exploit natural conditions. Just natural conditions out there. This is a man, he's an evolutionist, and he used design analysis. He was looking for a magnetite-based sensor in animals on how they might sense the magnetic field. Now, all of you remember from high school what magnetite is. It's an ore, and it has natural magnetic properties. It's like an iron-based ore, but it's a natural magnet. And they used to call it lodestone on ships to use it as a magnet. Well, interesting, he published a paper in 1981 where he predicted that organisms might use magnetite to actually detect the Earth's magnetic field. And he mentions there bacteria, sharks, honeybees, and all these other organisms are able to detect direction in the Earth's magnetic field and respond to very minute changes in its intensity. We knew that. And back then, he proposed a couple sensors. And one sensor had a magnetite crystal which could freely swing in a fluid environment, kind of like you've had a compass on a ship, it would spin around. And another one he proposed were having magnetite crystals which were attached to a hair cell which could be deflected by the Earth's magnetic pole. Well, that was his proposal, and that was using good design-based thinking to predict what might be in organisms. Well, in 2007, he published a paper showing that bats This actually does save me a little bit of time because I can just paraphrase it. Bats actually have a magnetite, it seems that magnetite receptor, that they're able to detect the Earth's magnetic field. And on top of that, it was demonstrated that this receptor was in fact a little particle of magnetite. But he still didn't know what it was. And then in 2012, he published a paper where they were actually able to find the cell for the first time. And this is the cell, and here's a tiny little microscopic particle of magnetite, and when you move a magnetic field around it, the cell will actually spin around, and the organism can detect that magnetic field. And he was able to show in a scanning electron micrograph, and here's the tiny microscopic magnetite particle, which is in this sensor. That's pretty incredible. That is really cool, to have a sensor that has its own little built-in magnet on that. Well, here's a picture of some marigolds, but if you look really, really close, you'll see that there's a bee on those marigolds. Now, bees also have a magnetite-based receptor in them. So they can do that. And bees have other cool visual capabilities, but as this paper shows, bumblebees sense electric fields in flowers. You can't see them, but the bumblebee can see them. And when a bumblebee has already visited a flower and taken its nectar, it changes the electric field on the flower, and the other bees can see that change, therefore they skip that flower and go to another one. Wow, that's a pretty impressive little sensor. I wish I had one of those. And all of us, we can see a rat or a mouse on that. But if you were in a room like this and I turned the lights out, it would be totally dark. Here. There we go. We go into a dark room. Wow. It would be hard to see that unless you had one of these infrared receptors. Or infrared, does it say receptor? Or does it say an infrared what? Sensor. A sensor. This is what man-made things are that could actually see that, and it would send a signal into this processor which would modulate things. So, if you didn't have one of those, maybe you could be a pit viper. And this article says that this snake, which looks like it has little nostrils up here, but those aren't nostrils, that is a sensor that can detect infrared radiation. And it sends it back to its brain, and the snake is able to see in stereo. And this says the pit viper's ability to register heat is so sensitive. It has 7,000 nerve endings with a density of 500 to 1,500 per square millimeter. And it is able to detect that mouse in under 35 milliseconds. Wow, that is a really cool sensor. We don't have one of those in our eyes, but if you were a pit viper, you could see this mouse, or you could see it, and that's what you would see, an infrared picture. Infrared picture, infrared device altogether. Well, let's talk about the sensors themselves. How do they actually sense and send a signal? It says the cells must constantly monitor cues from the environment and adjust their activities accordingly. Well, we have here a picture of one of these sensors up on the screen right here, and we're going to look at the input from the detector or from the sensor back to the logic center. And this is a sensor for a molecule in your body called platelet-derived growth factor. I just want you to look at the little sensor. You see, it's got two parts. Here's one part, and you can connect another one. And these little pink peas are a molecule of phosphate. And you notice you can put a bunch of them on it. Whether you have one or a bunch is sending a bit of different information back to the cell. And then you'll notice over here, attached to the peas, are other little proteins. And as they're attached, they will send a message to the cell, causing all different kinds of changes, including cell division. Well, you can obviously see there are a lot of different ways in which those can be configured. And this paper mentions how they can be configured, and since it's cut off, I'll just cut to the chase. It says that with just one of those put together, you can have 2 billion different types of information that can be sent back to the cell. And when you take in condition how the proteins can be mixed and matched, you get essentially a virtually infinite signal that can be sent back, infinitely fine. It's like taking the volume on your radio and it just the minutest change, sending different information back to the cell. Infinitely fine. These are the kind of things that God makes. That we're just like, wow, I wish I could build something like that. So you have these detectors, and then you have to send a signal back, and the signal can be essentially infinitely fine in its detail of the data that can be sent back to the cell. Wow. What about some sensors that enable two organisms to work very, very closely together in a mutual relationship? This paper is published within just the last 4 months. It shows what happens when a human being eats a little bit of food. The food goes into their gut. These are pictures of cells lining your gut. Bacteria live in the cells. They eat the food themselves. Their numbers increase exponentially. And once they increase, they start making other little proteins. Some of the proteins, the cells in your gut pick up and they dump them directly into your bloodstream. Others, it detects those proteins and they make other factors themselves, what they put in the bloodstream. And these flow back to your brain. And when they flow back to your brain, they give you the feeling of being full. Full, and it's the bacteria which are making these factors which your body detects, which goes back to your brain to give you the sensation of feeling full. In other words, stop eating. We should maybe listen to the signals a little bit better. And here's another one. And this is also fascinating. This paper was just published about a month ago. Again, it shows cells, big pictures of cells in your gut, and they're using DNA to make the messenger, which was called RNA. Remember DNA and RNA? And this is given a particular name. It's called fecal RNA. Fecal RNA, because it's dumped in with your fecal material. So your body takes its DNA, it makes these RNAs, it dumps them into the gut lumen. But why would RNA be in the gut lumen? Well, bacteria are able to sense those RNAs, and they have a transporter which is able to bring those RNAs into their cell, and they use RNA, which is made in your body, to process things and produce proteins in their cellular mechanisms. That's really, really interesting. That is very tight cooperation between two organisms. Well, how about this baby? Crying women turn men off. Well, now this was an interesting study. It caught my eye here. And it says, weeping releases a chemical that reduces sexual arousal. Women may have a more subtle way of telling men no than anyone imagined. Chemical cues in their tears signal that they're not interested. We're beginning to get some insights here, So what happens are, you make tears. So if I squeeze lemon in your eye, lemon juice, you'll start to cry. But if I show you a really sad movie or something sad happens in your life, you'll start to cry. The chemicals in your tears are different based on the cause. So in this particular experiment, they showed women very, very sad movies. So they started to cry, and they collected their tears. And then they got a bunch of men. Half these men were exposed to normal saline, salt water. They sniffed it. They sniffed a rag with salt water on it. The other half of the men sniffed the rag with the tears on it. Nobody could smell anything. Nothing. You can't smell it. But the men have a receptor. They have a what? A sensor that can detect that chemical in the tears. And if you monitor, with an intravenous monitor, their testosterone levels, the men who smell normal saline stays normal. The men who are sniffing this, their testosterone level goes down. And then if you show two groups of men pictures of the same women, this group finds the women attractive, this group finds them less attractive. Well, that's really, really interesting. That's very interesting here. I don't know why this guy's got a big smile on his face. He's out of luck. So anyway, that's the way it is, So if your wife's crying, leave her alone. That's the take-home message here. How about sensors that are able to track changing environments. This study was just published 2 weeks ago. It's on some fish. They're able to live in polluted water with hydrogen sulfide. Hydrogen sulfide is the gas that kind of has the rotten egg smell, but when it gets in water, it turns the water acidic. You would think it would kill the fish. This is a fish that lives in water that's non-polluted. This is a fish that lives in water that has been polluted by hydrogen sulfide. It's clearly not dead. It is able to adjust multiple mechanisms within inside it to keep the hydrogen sulfide out, or when it does get in, to metabolize it, or to use it in different ways. And guess what? It has a detector for hydrogen sulfide, and those detectors are located on their gills. Makes sense. They're pushing water past their gills constantly, and they're able to detect that. Now, a lot of us think when these things happen, you want to know, well, what's the gene that was changed? How many of you said that? Or someone comes out and they're looking a little different. You want to know what the gene is. I'm here to tell you it's not that simple at all. The next page in this article, which is showing how they have an output mechanism in their bodies, you don't have to read it. It's there for impact. The title of this list is the genes that are consistently upregulated in fish that detect hydrogen sulfide. And you'll notice it says what here? Continued. It's not a gene that's upregulated. It's dozens of genes that are changed. And the next page on the article, go back, shows the genes that are consistently downregulated. Massive changes, not simple changes, massive changes in these organisms take place. Well, how many of you remember the Chernobyl accident where the Russians had their meltdown and it polluted a bunch of land with high radiation? Very, very deadly areas of radiation. But it's not deadly for all creatures. There's lots of creatures that live in that. Here is a picture showing how, I wish it wasn't cut off here. Anyway, the bottom line is this. It shows that these plants and animals are able to move into this high radiation area by regulating the rate at which they repair DNA damage, going up over 15-fold. And what's interesting is animals that are living in this radiation zone, not only do they repair the damage to their DNA from the radiation zone, they're able to repair it better when exposed to all types of radiation. That's really, really interesting on how that happens. And here's a picture of these birds that are living in the zone. They've adapted themselves. They were not adapted to, they adapted themselves. Now, I don't believe, I'm just speculating, that high radiation areas were places that were normal on the earth right from the beginning of creation. But these animals had the capacity in them already to be able to be fruitful, multiply, and fill environments, even ones that have been polluted by high radiation from Chernobyl. And it's hard to get, by mutation, a mechanism that upregulates the way to fix mutations. It doesn't make any sense. Wow. As therefore, it's not magic, as Mazda says. It's engineering. It's incredible engineering. It's the Lord's engineering which enables all of these things to happen. And then finally, sensors and detectors that enable organisms to track changes over multiple generations. What this is basically saying is, this paper was published on March 28th. Today's what, April 8th or something like that. Very, very recent. This is saying that we are able to adjust to environments not by changing our DNA, but by changing the way the DNA is expressed. And this paper says that it was not a simple mechanism, but it is a highly regulated mechanism that is actually tunable to the conditions, that can be readily turned on and off. Wow, that is really interesting. And therefore, that's why it says guinea pig are able to beat climate change by tweaking their own DNA in real time. And their offspring are able to adjust to these changes. And here's an interesting study. Obese men found to make sperm with thousands of modified genes. And this was a study that looked at obese men. And they found that those markers on their genes were changed and were transmitted to the next generation, and their children were more likely to be obese on that. And it wasn't just a simple change. It compared 13 lean men and 10 moderately obese men, and they found, you cut off here, 9,000 genes. 9,000 that were modified by this. And then it goes on to say, I'll just blip through these very, very quickly, that the changes were not permanent. Once these men had gastric bypass surgery, which changed how much they ate, 1,500 genes had been modified back within 1 week, and a year later, 4,000 genes had been altered. So you can see it's a highly dynamic adjusting system. Highly dynamic. And this allows organisms to face environmental changes. They flex, and they're able to take them on, but then it kind of goes back to normal within a few generations. Very, very interesting. So then we ask the question, what makes any condition a stimulus? And I mentioned this a couple days ago. Why aren't we listening to AM radio? Because we don't have a receptor or a detector for that. And how anything in real engineering terms is made a stimulus is the engineers define it to be a stimulus for a specific purpose. And then they'll give you a detector and able to find those conditions. Environmental conditions never, in and of themselves, become a stimulus. They must be defined to be a stimulus, and you must be given a receptor for it. And this is showing not just cruise control, but adaptive cruise control. What that means is, as you're driving up the road, your car doesn't just adjust speed up and down to hills, but as cars are varying in their speed, it adjusts its speed so that you don't run into a car automatically. And guess what's on the front of this car? A detector, which is able to detect those other cars, and it's the detector which adjusts the car, not the environment around it. And therefore, when you have a sensor like this thermostat, the air temperature doesn't determine whether it's a stimulus. The thermostat itself determines whether anything is a stimulus. And then finally, that gets us to the last question. What makes anything a real trigger? A real trigger. Because many times they're going to come up and they're going to say, the environment triggered this. The environment triggered that. The environment induced this. Where do the real triggers reside? Well, let's look at that. How many of you remember this guy? Dirty Harry Callahan he was from California, wasn't he? On there. And how many of you have ever seen the movie? Oh, you guys, everybody's honest there. And you remember he chases a criminal out of the building, shooting at him. Bang, 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 bang. And the criminal's on the ground, and he asks him, you're probably wondering whether I shot 5 or 6. You remember that? And then he asks him, well, do you feel lucky, punk? Remember that? Do you feel lucky? Well, the question is the trigger a lucky punk who feels lucky or not? Is that what's going to cause his gun to go off? And then a little bit later, Clint Eastwood made another movie where he chases people off his lawn with his Garand. Get off my lawn there. Well, that's an interesting question. Let me suggest to you that the trigger of this gun is the trigger. That is the real trigger. It's not a lucky punk. It's not his dad who made him go into a life of crime. It's not any of those other things which people generally refer to as triggers. But in real design terminology, real triggers are always part of the entity itself. That's when you know what the trigger is. And that's why birds are able to detect magnetic fields, but not with a magnetite receptor, but with a protein which is able to detect those and relate it to the horizon if they're flying in day, or to the stars if they're flying at night. And what's interesting is, in human beings, they found that same detector. And it says this detector, human cryptochrome, has the molecular ability to function as a light-sensitive magnetosensor, and this finding may lead to renewed interest in human magnetic reception. But I think it's only in men. Anyway, that's true. Wow, we have some really interesting sensors and detectors. And when you can look inside these organisms, you can find out where the true causality really resides. They're not being shaped by their environment. In other words, environmental challenges and pressures are not designing organisms, but rather designed organisms take on environmental challenges and solve them. And that was what really brings glory to the Lord. Amen? Well, thank you so much.